Hi guys, welcome back to a new video. So onto the topic of deleting a soldered 9th generation Coffee Lake CPU like the 9900K. So I haven't really been into this topic since the original launch of the 9th generation CPUs, like around almost 1 year ago. Of course I've known that you can delete these 9th generation CPUs just like the 9900K and improve the temperatures for daily use, like on air or water cooling, by quite a bit by using liquid metal between the CPU die and the IHS instead of the stock indium solder that Intel uses with these CPUs. There are many reasons behind it, that's why I haven't buffered with it. So there is a real risk involved when you delete the CPU, and also since that I tend to use since that I tend to run my CPUs on cold, like on LN2, there's like no real benefit for LN2 overclocking from deleting the CPUs. So for subzero overclocking, indium solder is the best possible thermal interface material between the CPU die and the IHS. First of all, it doesn't really crack, so the whole CPU is crack free there, and also the indium solder has better thermal performance than any like conventional thermal paste, like for example the Kimping Cooling KPX over here. So liquid metal is the only thing that can beat the indium solder in terms of temperatures, but it cannot really be used when the CPU is running at sub-zero temperatures. So the performance of liquid metal thermal interface material goes really bad after like plus 10 degrees. So that the only real advantage of deleting the CPU is for air or water cooling, aka for like normal daily overclocking rig. So that's why I haven't really buffered it. I know that you can improve the temperatures by quite a bit by just removing the indium solder layer there and using liquid metal. The main reason behind it is that well, technically the indium solder has quite good thermal performance in terms of watts per meter Kelvin, but the layer is actually quite thick, so you can make the layer much thinner when you use liquid metal, and you can even improve the temperatures even more by lapping the CPU die down, so it becomes more even, and it also makes the overall die size or the thickness of the die like smaller or thinner, so that way you can improve the temperatures even more by going more hardcore about it. But I don't really see the point, so but now I wanted to give it a shot, as here's my original 9900K PO stepping engineering sample that I got like with the original dark board, the ES, the engineering sample board, like back in last year's November. So this is not a really like golden chip in any case, so it only can do like 5.3 GHz for multi-core tests on water cooling. 5.4 is absolutely impossible, I have tried it many times, and also for LN2 overclocking it's not good at all, so it cannot even reach full pot temperatures no matter what I set in, pretty much. So I don't have any use for this chip for like LN2 overclocking purposes, so I can use this chip to try the deleting process for you, and we can try how the temperatures get improved by using something like thermal grizzly conductor nut between the CPU die and the IHS, and then just normal conventional thermal paste between the IHS and the cooler itself. And so I got this Rockitcool QuickSilver, so this will help us to remove the indium solder residue layer from the CPU die. So this doesn't cost that much at all from a Rockitcool store. I got this and it came fast by FedEx, so I decided to get it, as I really want to make the layer good, and I want to get rid of all the possible residues that is left by the deleting process. So apparently the indium solder used on this CPU generation is quite like soft, so you can delete the CPUs just like normally. Of course it requires a bit more force than if it was just on normal conventional thermal paste, but you can use normal deleting tools. So you can buy a deleting tool for 9th generation CPUs, especially from Rockitcool as well. But I decided to give it a shot with this old rotation polyacetal delete tool made by a Finnish guy at our tech website called IoTech PBS forum. So his nickname there is KRI21. This deleting tool is no longer produced, so you cannot get this anymore. But he did sell this for quite a while during like Skylake and Cave Lake days, for even internationally. So I happened to get it, and for some reason it seems that I'm not fully sure if this is the Ivy Bridge or Haswell top, but it fits the 1900K perfectly. So I just thought that why buy a new delete tool when I can use this? So this should work. I'm almost sure, or I'm pretty much sure that this should work just fine, and the CPU should not get damaged. Also, we can try. I decided to get the Rockitcool direct die frame, so we can also try direct die cooling on the 1900K, and I also got a custom IHS for the 1900K. So I have all these options over here. So we can test just how the deleting tool, how the deleting process as a whole helps the temperatures. Then we can also compare what is better, custom IHS or just directly to direct die solution. So we can test those. So I wanted to give it a shot. So I think without further ado, we can see how we can get the CPU deleted, and then we will look at how to clean the CPU die with the QuickSilver, and then we can get on to the actual tests. So let's get going. So this is a little bit different than normal deleting tool. So this does not push the IHS back and forth. This will rotate the IHS. Now I'll take it back. So it really felt that it gave up a bit. So yeah, it's not so easy with this tool as I thought. So it has given up a bit. So the glue is now loose, but it's still holding a bit. So I think I need to put it one more time in the tool. So it has definitely like given up. So now I can just put the CPU there, and I can just rotate it at the end with just fingers. So it has given up, but there's still something like holding it. So it did not require like no force at all to do this. So I don't see why it wouldn't. I don't see that any reason that why it would break so easily by just doing this. So this is actually quite gentle way to delete the CPUs. Yeah, now we are definitely getting there. So if you look carefully at the IHS, it does twist now quite a bit. Looks really solid if you ask me. Like, I don't see any reason why it would have damaged. So it's really good thing if it works just like this. So no need to buy a new delete tool, just use old one. I think this is the top part for, I'm pretty sure this is the Ivy Bridge one, but it's either Ivy Bridge or Haswell one. So yeah, it's the Ivy Bridge top. So I tested it with this Pentium G3258, which I recently got for Z97 power chip testing. So this is the Ivy Bridge top. So it will fit the 1900K just fine, as long as this just works. But yeah, so you can utilize that if you have an old delete tool with an Ivy Bridge top. So here's the actual IHS and the die. Now we will use the QuickSilver to get rid of all this indium solder residues on the gold plating on the IHS side and also on the top of the die. Now one thing that I don't ever do with CPUs that I delete, so I do not remove the glue, the black glue residues on the PCB. There's reason why I don't do it. So I really don't like when the when the glue is removed both on the CPU PCB as well as on the IHS side. There's like small gap between the edge of the between the edges of the IHS and the CPU PCB itself, so it like twists and wobbles all over the place. So the only spot where it is secured together is the actual CPU die. So for example, if you use liquid metal, it's really slippery. I think I have an example CPU over here. Here's a Core i5 3570K. So this doesn't have the glue on, so this is like really slippery and wobbles a lot. I don't like this at all. So when you clamp this down to the motherboard socket, it's really annoying to get it straight and in perfect positioning. So that's why I don't do it. It will work just fine if you leave the glue around the PCB. I mean around the die on the PCB. So then it will not be so slippery and it will still have perfect contact to the actual die with liquid metal. So when I have been doing the test that is there a temperature improvement when you don't remove the glue versus when you remove the glue and try to get the 100% contact between the CPU die and the IHS, and I haven't really noticed any difference whatsoever. So I stopped doing it. So now it's very easy to get the IHS in perfect spot on the CPU PCB itself, and very easy to clamp it down to the motherboard socket. But now, without further ado, let's get rid of the solder residues on the CPU parts. So I think you can first remove most of the solder residues with something plastic, like over here. So yeah, it is a little bit thick, but it should. Yeah, it's actually quite thick, so let's apply the QuickSilver just like that, both on the IHS and also on the die itself. I think this should remove most of the solder residues from the metal parts. So, as these components are quite delicate, I don't want to use too much force, so I wouldn't go straight with something sharp like knife or anything to remove the solder residues like that. So I think it's better to play it safe and use time. So yeah, the Rockitcool QuickSilver definitely works. So with this short duration, I managed to get rid of most of it. I'll put one more layer of the QuickSilver on the die to get rid of all this indium solder residue off from the die to get the best possible contact to the actual IHS again. Otherwise, we will not get that much benefit. So the actual CPU die looks quite good already. So once I used the QuickSilver to get rid of most of the actual visible solid indium solder residues off, I used the flitch polishing paste or grease that comes with the Rockitcool QuickSilver kit. So this helps to remove all the remaining residues on the metal surfaces and get the actual surface very clean and polished. So I'll put it on the IHS part as well, and use just a normal cotton pad to spread it and wipe the spot on the IHS that the actual CPU die will touch to get it clean and polished. Now I'll just use some paper with alcohol to clean it off, and soon we will add the liquid metal and see how the temperatures look like. Alright, so that's how it pretty much looks like. So I think it's quite good. So I can see that there's maybe something a little bit left at the edges after using the polishing paste, but I think this should be good enough to try with liquid metal now. So we'll be using a thermal grizzly conductor nut on the CPU die for best performance. I also have that new collaboratory liquid metal as well, but as I already compared the two some time ago, the conductor nut is better option. I think that should be ample amount on top of the CPU die. Then we'll just use some normal cotton pad to spread the liquid metal, just like you would normally. So that the whole die is covered, but you don't have to put too much, otherwise it will just like jump from all the excess will like go all over the PCB. I'm not sure if liquid metal can short anything over here. As you can see, those like 3 or 4 golden contact dots over here. I'm not sure if anything could short from those, not sure, but this should be okay enough. So now we will just hook up the CPU back to the EVGA Z390 dark socket and we'll test the temperatures and if the CPU still works, but I think it should work. I don't see any reason that why it would be damaged. There was no too much force applied at all when doing the Delid process. You can also apply a separate layer of liquid metal to the IHS part of the CPU as well, but usually just applying it onto the die is enough to get the best possible performance. You can also see that I removed the original black silicone glue from the edges of the IHS, but I kept it all on the CPU PCB, just like I told at the start of this video. So the glue was kind of bumpy on the IHS side, so I decided to remove it, but by keeping it on the IHS it will still be quite easy to clamp to the socket, and it will not be so slippery like if compared to how it would be if you removed it all. Alright, so now that the CPU has been clamped successfully to the CPU socket, we can actually check what the rig looks like. So the motherboard is the EVGA Z390 dark again, with the Delid 9900K PO engineering sample CPU with 2 sticks of HyperX Predator 4133 Cas19 sticks, so Samsung B-Die A2 PCB. Then there's the graphics card is the EVGA 2080 Ti Kingpin edition, then just custom water cooling loop, and the power supply is the Superflower LEDX 8-pack 2000 watt. So we can see if it posts. So there's no heart attack or anything. So successfully in the BIOS, and the BIOS reads 27 degrees for the CPU temperature. So now we can actually test how the difference looks like. Alright, so on to the conclusion. So before even starting this whole process, I ran the temperature results of the stock configuration, that what we can compare against after the Delid. So I ran the CPU in Cinebench R15 at best core frequency that it can roughly do on water. So I ran it at 5.3 GHz and 4.8 set on the cache, with 1.375 set on the V-core. And I also ran the CPU 10 to 15 minutes in Prime 95 26.6 version. So that is the last non-AVX version of Prime 95 at 5.1 GHz, but with exactly the same V-core, as you cannot run exactly the same core frequency in Prime 95, even if it's the non-AVX version, than what you can run in Cinebench, as the Prime 95 is a harder test to pass overall. So well, that is enough to just see the temperature results, so you don't have to run it like hours and hours to get the to see the maximum temperatures that it will reach. So it will get there very fast. And after the Delid, I used thermal grizzly conductor out between the CPU die and the IHS, and then just normal conventional thermal paste again between the IHS and the CPU water block. So the conventional thermal paste was thermal grizzly cryonaut in this case, both before and after the Delid. So I ran exactly the same tests and clock speeds and voltages after the Delid to just see the actual temperature gain. Throughout the tests I monitored the ambient room temperature with K-type thermocouple, and it didn't really vary much at all. So the ambient room temperature varied between 21.5 and 22.2, so very small fluctuation there. And now when looking at the overall temperature results, the average value of the maximum core temperatures before the Delid in Cinebench at 5.3 was 77.0 degrees and 83.0 degrees in Prime 95 26.6 after 15 minutes or so. And now after the Delid, the average value of the core maximums in Cinebench dropped to 75.125 and 82.5 in Prime 95. So we can pretty much conclude that the overall gain is very minimal. So we are talking about maybe a few degree drop in best case scenario. So this is a very small improvement that you can do by deleting a soldered CPU like this. So this end result is much like lower compared to what De Bauer got in his original video almost 1 year ago. But in De Bauer's video he compared the overall average values throughout the tests, as when you test the temperatures of a CPU in tests like Prime 95 or similar, it can sometimes peak up for a few seconds, then it will come back down very, very quickly. So if you do it that way, then you will get a bit higher like temperature differences there, because if you just compare the absolute maximum values that it has recorded, then the overall difference is smaller. But anyways, so if I have to conclude anything, I think this is not worth the risk. So you will take a lot more risk when you delete a soldered CPU compared to normal, like conventional thermal paste CPU. So I don't really see it that worthy thing to do just by this. Of course, I haven't tested the custom IHS or the direct die frame yet, so we might get better temperature results with those. But I will make a separate video about them where I compare the two solutions against each other. But just the Delid process as a whole is definitely not worth it, because now I pretty much have PO stepping 9900K here, that is just a few degrees cooler than before in best case, but now I have lost the maximum capabilities for LM2 overclocking. So now I could never reach exactly the same end core frequencies under LM2 that I could have before doing this whole process. As I told at the start of this video, you will not gain same temperature performance with conventional thermal paste than what you can get with indium solder, and also conventional thermal paste can crack, whereas indium solder will never crack, and well, you cannot use liquid metal TIM under subzero cooling. So that's the overall conclusion. So personally I don't see it worth thing to do, so I don't really recommend it. But if you want to try it, then I can happily recommend the QuickSilver kit from Rockitcool. It really helped a lot to get this thing done. So the QuickSilver really helps to remove all the indium solder residues from the two surfaces. So get that kit if you really want to try this, as it is not expensive at all. As I haven't tested the direct dye solution or the custom IHS yet, so I cannot really compare. I cannot really advise yet that should you buy either of those as well. But anyways, so if you have done this yourself, or if you have any comments or questions about this whole process, then please leave them down below in the comments section. If you like this video, then please subscribe to my channel, as I want to get more followers to watch my videos, as I want to make these just for you guys. And also like and share this video. And other than that, thanks for watching this video, and I'll see you next time.